Welcome back everyone. In the previous video we walked through the project wine and trying to apply PCA to extract the principal components. Recall that there were 13 features that come with the wine datasets. It starts from alcohol, malic acid, ash, and on it goes. There are 13 of them. We wanted to actually see if we can reduce this large dimension. 13 is quite a lot, so we really want to actually reduce it down. So the process that we went through was actually the scaling the data, scaling in particular the X-train data, and then transforming it, and using the transform X-train we applied to the PCA to it. So I'm just going to jump straight to applying the PCA to the X-train scale data without specifying the number of components specifically. So these are really the actual process, and after that we looked at the actual explained variance ratio. We look at the cumulative sum, and what we see is that around the fifth component you achieve 80%, and that's assuming that's what the goals that you have. 80% is fine. Then all you really need is only 5 components instead of 14 components. So that's really the basic ideas here. Now the only thing is this: when you look at the transformed X-trained scaled data, or scaled X-trained data, after you actually let me just copy this, something came across wrongly. Okay, let me just copy this, and if you look at this, it's a little bit hard to interpret, even if you actually converted it to a pandas data frame, because we don't have any label. So what we're going to do is just store that into a variable, and what you have really is that these are all the 13 features itself. So what we want to do is actually, instead of not having a name, so let me just show you first. Data frame, let's just call it RS. You notice that there are 13 features here. It's just, but this name is 0 to 12, and that's kind of like, what does that mean? So we're gonna just give it a name that is actually a little bit more meaningful. Okay, so we're just gonna use the pandas underscore here, Python list comprehension. So this is kind of like for loop. Okay, so for k in range from 0 to the length of rest. Okay, what this is really saying is that for every value that is in the range from 0 to the length of res, so basically 0 to 12, and when k to 0, you convert k into a string, meaning 0 to a string, and add it to PC underscore. So if I run that, and I'll just show you what the index name becomes, it'll basically be PCA 0, 1, 2, 3, all the way to all of the whole length itself. So let's just delete that. Okay, having done that, so the next thing that we really want is just convert this to a data frame. But we do want to actually add other names. So the first thing is the columns. The columns name would be the original data frames columns name, okay, from 1 onwards, because the first column, which is column 0, is actually the wine, the class of wine. Okay, now that we've done that, the actual index itself is the index name that we just created above. Okay, so I'll just visualize df1, and this is what we have. Now, I don't know about you, I don't really want to see all of these, so let's just select the first 4. Okay, and then the next one that we want to do is just transpose this so that we can actually read easily. Okay, so, and sort it by the first PCA. df1. Okay, we need to do this. Yep. Okay, this is showing the first 4, which is that's because we selected it as 4 here, and you can see that it's ranked based on PCA, the first component. Of course, you can start from 1 here, but we'll just leave it for now. What you can see here is malic acid is related to principal component 0 minus 3.6, and total phenol is 3.06. So that's kind of like, okay, finally I can relate the principal component to the actual original feature itself and see how the two are related. Because before, it's really difficult when you look at PCA 0, what does it actually mean? Whereby now, looking at this way, you can see, oh, okay, I understand now. The malic acid is negatively, in a way you can say, is negatively correlated to PCA 0 to the tune of 3.6 per unit. And the total phenols is 3.06 unit relative to each unit of PCA 0 or PCA 1, principal component 1. So that's basically the basic idea here. I really want to highlight this so that the PCA is not a black box, just to help understand the actual the actual intuition of the actual machine learning algorithm itself. With that, I'm going to end this portion, and thank you for watching. What we cover here really is how to actually visualize in a way or present our principal component in a manner that is easy to understand. And the last thing that I really want to leave with you is the project itself. I hope you actually attempted the abalone projects. I've copied the whole codes onto a new Jupyter notebook rather than combine it to the back of the project wine. This is not part 1 anymore. Both the part 1 and part 2 are together, so I'll just call that project wine. And if you look at the abalone, this is my whole result. As it turns out, all I really need is actually one principal component that will explain 84% of it. So I hope that's been useful, and thank you for watching. I look forward to seeing you in the next lesson. Thank you once again.